Hello students, today we are going to start a new chapter, chapter 12, friction. You have learned about frictional force in chapter 11, that is force and pressure. You know that a ball rolling along the ground gradually slows down and finally comes to rest. When we stop pedaling a bicycle, it gradually slows down and finally comes to a stop. Same way, a car or a scooter also comes to rest once its engine is switched off. In all these situations, no force appears to be acting on the objects, yet their speed gradually decreases and they come to rest after some time. What causes a change in their state of motion? The force responsible for changing the state of motion of objects in all these examples is the force of friction. It is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Similarly, friction between water and a boat that brings the boat to stop once you stop rowing the boat. The force of friction always acts on all moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of contact force. Now, listen to this activity that shows the force that opposes the motion of the object. That means we can study the frictional force. Gently push a book on a table. See the first figure, that is A. You can see that the book will stop after moving for some distance. Repeat the same activity, pushing the book from the opposite direction, that is shown in B. Does the book stop this time too? Yes. When we apply the force on the book along the left, friction acts along the right. If we apply the force along the right, the friction acts along the left direction. That means friction always acts in a direction opposite to the motion of the objects. Or we can say that friction opposes the applied force and acts in a direction opposite to the direction of motion of object. Here, in this activity, the force of friction acts between the lower surface of the book and the upper surface of the table. And what you can conclude from this activity? The force which opposes the relative motion between two surfaces in contact, when force is applied to one of the surface, it is called force of friction. That is, the force that opposes the relative motion between two objects in contact is called friction. The force of friction acts on both the surfaces. The force of friction always opposes the applied force. Now we can see on what factors the frictional force depends on. That is the factors affecting friction. See the activity which is given in your textbook. Tie a string around a brick and place it on the table. Then pull the brick by a spring balance as shown in the figure. So for that we have to apply certain force. Note down the reading of the spring balance when the brick just begins to move. Now what you have to do is wrap a piece of polythene around the brick and repeat the same activity. In the first case, we can see that when the brick just begins to move, the spring balance shows some reading. In the second case, when the brick is wrapped with polythene, the reading of the spring balance shown will be less than that of the first reading. When polythene was not wrapped, that means when polythene was not wrapped on the brick, the surface of the brick was rough. So there is more frictional force between the brick and the surface of the table. That's why the readings shown by the spring balance was more in the first case. When the brick is wrapped with a piece of jute, you can see first the brick as it is, second one as it is cover with a polythene, and the third what you have to do is cover it with jute. That time we can see that the reading shown by the spring balance, it will be the most. So when it is covered with polythene, the reading is the least. Then the brick as it is, little more, and when it is covered with jute, the reading will be the most. This shows that the brick experienced greater frictional force when it is wrapped in jute and smaller frictional force in case of polythene. What did you understand from this? The force of friction is greater as roughness of the surfaces in contact it is more. We can see another activity that will be shown in the given video. See that here we will learn about the effect of smoothness of a surface or roughness. The things required is a wooden board, 3 bricks, a torch cell, cloth and some sand. Make an inclined plane on a smooth floor or on a table. With the help of the bricks, we can make an inclined plane. See that with the support is given with the help of the bricks. Now, a torch cell is kept on the wooden board. Let it come down. We can mark the point where the torch cell stops. Then spread a piece of cloth over the table. Try the activity again. Then again mark the point where the cell stops. Now repeat the activity by spreading a thin layer of dry sand over the table, and again you can mark the point where the cell stops. Here, in which case the distance travelled by the torch cell, it is more. Here see, in the table less resistance is offered, and when it is covered with the cloth, it covers less distance, and when it is covered with sand, the distance travelled will be less. As the roughness of the surfaces increases, the distance travelled by the object, it becomes less. This shows that the frictional force depends on the nature of the surface. If the surface is rough, the frictional force exerted will be more, and if it is smooth, the force of friction will be less. Friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities on the two surfaces lock into one another. That means even though the surface appears to be the smoothest, there are irregularities. And these irregularities on the two surfaces, they lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surfaces, there are a large number of irregularities. So the force of friction is greater if a rough surface is involved. Is that clear? The next topic, friction as necessary evil. So friction is necessary in many cases. So what are the uses of friction in our daily life, or how it helps us in our daily life, we can see. While walking, friction allows us to walk comfortably on the road. That means the friction between our foot and the road, it helps us to walk. It allows us to write on blackboard with the chalk as well as on the paper with a pen or pencil. While writing, friction between the pen and the board, or the pencil and the book, or the chalk and the board, that helps us to write. If you want to fix a nail on the wall, friction between the tip of the nail and the wall helps us to fix it properly on the wall. So these are the uses, or how friction helps us. And friction acts as a foe also, or as an enemy also. The first one, it causes wear and tear in the objects. Second one, when a machine is operated, heat generated causes much wastage of energy due to friction. Some parts of the machine, it is damaged due to friction. That means the parts of the machine gets damaged due to friction. Third one, it opposes the motion of the moving objects. As a result, speed of the object decreases. Due to friction, the speed of the object decreases. Friction produces heat. When a machine is operated, the heat generated causes much wastage of energy. That's another disadvantage of friction. Now we can see certain ways to increase friction. Have you ever thought why the sole of your shoe is grooved? It is done to provide shoes better grip on the floor so that we can move very safely. Similarly, the treaded tires of cars, trucks, and bulldozers provide better grip with the ground. We increase friction by using brake pads in the brake system of bicycles and automobiles. When you are riding a bicycle, the brake pads do not touch the wheels. But when you press the brake lever, these pads arrest the motion of the rim due to friction, so the wheel stops moving. You might have seen that while playing kabaddi, the players rub their hands with soil for a better grip of their opponents. Same way, the gymnast, they apply some coated substance on their hands to increase friction for better grip. Now, what are the methods of increasing friction? See, the sole of the shoes are made up of grooves to increase friction. The tires of the car, truck and bulldozer are made up of treads to increase friction. The brake pads are used in the brake system of bicycle and automobiles to increase friction. Kabaddi players rub their hands with dry soil for better grip. Gymnasts apply some coated substance on their hands to increase friction for better grip. These are certain ways to increase friction. Now we can see how friction can be decreased. You must have seen that while playing carom, some talcum powder, it is sprinkled on the carom board. It helps the striker and the coins to move smoothly on the board by reducing friction. Second one, a few drops of oil are poured on the hinges of a door and also window for the smooth movement. It reduces friction. Bicycle and motor mechanics, they use grease between the moving parts of the machine. In machines, oil, grease or graphite is applied between the moving parts of the machine. In some machine, it may not be advisable to use oil as lubricant. An air cushion between the moving parts is used to reduce friction. That means in some machines it's not desirable to use this oil as a lubricant. So there, what reduces the friction? An air cushion between the moving parts. It is used to reduce friction. Now my question is, what is a lubricant? Lubricant is a substance which is used to reduce friction. Example, this oil, grease, etc. These are examples of lubricants. Now we can see the different types of friction. There are three types of friction. They are static friction, sliding friction and rolling friction. First we can see what is static friction. The friction that is produced between two surfaces in contact with each other and one of the surface start moving from the position of rest is called static friction. That means the friction between two surfaces in contact with each other when one of the surface start moving from the position of rest. The friction offered is called static friction. This friction is more than the other frictions, that means sliding and rolling friction, because its magnitude depends on the interlocking between the two surfaces. And to overcome this static friction, a lot of energy is required. Second one, sliding friction. The friction that arises when two surfaces in contact, they have relative motion is called sliding friction. Otherwise we can say when one object slides over another object, the friction offered is called sliding friction. And sliding friction is lesser than static friction because in this friction, irregularities of surfaces, they do not get enough time to lock with each other as the surfaces are already in motion, because the surfaces, they are in motion. That's why. The last one, the third type of friction, it is rolling friction. So sliding friction, I told you, when one object slides over another. Here rolling friction, when one object rolls over another surface. The friction offered is called rolling friction. The friction which arises at the contact surfaces when an object rolls on the other surface is called rolling friction. And it is a least friction than static friction and sliding friction. You must have seen luggages or the bag with wheels. See here. So the wheel, it reduces the friction. And another picture you see, the ball bearings which are used to reduce friction. Next, the friction offered by fluids, called as fluid friction. You know that air is very light and thin, yet it exerts frictional force on objects moving through it. Similarly, water and other liquids also exert force of friction when objects move through them. And in science, the common name of these gases and liquids, it is fluid. So what is fluid? The common name of liquids and gases, it is called fluid. So what is fluid friction then? The friction offered by fluids, it is called fluid friction. The frictional force exerted by fluids is also called drag. So what is drag? The frictional force exerted by fluids is also called drag. The frictional force on an object in a fluid depends on its speed with respect to the fluid. The frictional force also depends on the shape of the object and the nature of the fluid. And you know that when objects move through fluids, they have to overcome friction acting on them. And in this process, the objects they lose energy. So to overcome or to minimize this friction, the objects they are given different shapes. See that the birds that fly in the air, you must have observed the shape of the birds. That means the body is designed in such a way that they can overcome the friction offered by air during their flight. Aeroplanes, they have given a particular shape to overcome the friction offered by air. Fishes and boats, while moving through water, they also have to overcome the friction offered by water. So their shape is in such a way that they can overcome this fluid friction. So airplanes are designed to have streamlined shape. So the shape given to these birds, that airplanes, what it is called? It is called as streamlined shape. So the force exerted by the fluid, that means in case of aeroplane, what is there? The force exerted by the air on the object depends on the speed of the object with respect to the fluid, then shape of the object and nature of the fluid. When the aeroplanes, they fly, they do not have to lose energy while overcoming the frictional force exerted by air. So in order to reduce the friction, the airplanes, they have given a special shape that is called as the streamline shape. So I hope the portion or the topic, that is friction, is clear to you. Read the textbook thoroughly and understand the points very well. Okay, thank you.